Hi everyone, I hope you all are doing good. So, good morning, good afternoon, and good night to all the viewers. Okay, so what is a visitor pattern? In my today's session, I'm going to cover this visitor design pattern, which is belonging to the behavioral category of design patterns. So, a visitor pattern separates the algorithm from the object structure. Okay, because of this separation, new operations can be added to existing object structures without modifying the structure. So what it is saying is basically a visitor pattern separates the algorithm or some functionality, okay, from the object structure. Object structure is basically a collection, okay, which contains maybe homogeneous elements or heterogeneous elements. Okay, so the main agenda of this pattern is that it separates the specialized algorithm from this object structure, and because of this separation, new operations can be added to the existing object structures without modifying them. Okay, it is one way to follow the open close principle in object oriented programming. Yes, I agree, because what you are doing is, in order to implement a specific algorithm or functionality, you are not going to directly change the object structure class itself. No, you are not going to do that. Instead, you basically implement by implementing these specific algorithms into new classes. Okay, so that's why it is one way to follow the open close principle in object oriented programming and software engineering. In essence, the visitor allows adding new algorithms to a family of classes, okay, without modifying the classes or the object structure classes. Instead, a visitor class is created that implements all of the appropriate specializations of the virtual function. That's I'm going to show you soon. The visitor takes the instance reference as input. For example, the visitor takes the element of a aggregate object structure as the input and executes the algorithm on it. Okay, so that's what is visitor design pattern basically. Okay, so just take an example, guys. Suppose you have an organization or a IT company. Okay, so how you can visualize your organization or IT company is a object structure. Okay, and then who is the visitor? Visitor is someone who comes and provides some services like a cloud trainer. Okay, a cloud trainer comes to your company and provides training on Azure AZ900 certification. Again, this is one more example of visitor is, again, one salesman will visit your company and he will provide, okay, laptop accessories and laptop bags to your company employees. Okay, so can you see, they are basically visitors. They basically visit your object structure and provide the services, and once the service is done, that's it. They are not at all coupled with your company or object structure. Okay, so there is no coupling itself. So that is the essence of this visitor pattern. Okay, so let's move on. What problems the visitor design pattern solve? Okay, first of all, it should be possible to define new algorithms or functions for some classes of an object structure without changing the classes. Okay, so that's what I already explained. You should implement new algorithms or functionalities without changing the object structure. In our example, the company or the IT company itself, the company class itself, basically. When new operations are needed frequently and the object structure consists of many unrelated classes, okay? Always remember, object structure over here is a kind of collection which contains a mixture of objects, okay, which are not in homogeneous in nature. Okay, the objects are completely unrelated, but you want to provide some functionality to them. Okay, that's why they mention when new operations are needed frequently and the object structure consists of many unrelated classes, it's inflexible to add new subclasses each time a new operation is required, because distributing all these operations across various node classes leads to a system that's hard to understand, maintain, and change. Okay, so this is the problem basically for which visitor design pattern provides a solution. So what solution does the visitor design pattern provide? Okay, design a separate object which is called a visitor object that implements an operation to be performed on elements of an object structure. So my visitor wants to provide, for example, my cloud trainer wants to provide a easy 900 training to my company employees, then I will define a separate visitor called cloud trainer visitor. Okay, object that implements an operation to be performed on elements of an object structure, which is my organization. Clients traverse the object structure and call a dispatching operation except on an element. Okay, so client program basically, or your client, in my case, the program or the administration team, okay, what they do, they basically traverse the object structure, my company, okay, they will traverse through my company for each and every employee, okay, and call a dispatching operation called accept. They accept the training invitation sent by the trainer, okay. So they will accept the visitor, my cloud trainer, on an element that is my employee, okay, and then that dispatches or delegates the request to the accepted visitor object, okay. So what happens is on the accepted visitor object we call the visit operation, okay. What it does, so in my case the visitor will perform his visit operation on my employee, so that is nothing but providing the training. The visitor object then performs the operation on the element. This makes it possible to create new operations independently from the classes of an object structure by adding new visitor objects. Yes, so that is the flexibility. It makes it possible to create new operations independently from the classes of an object structure by adding new visitor object. Okay, you are not required to make any changes to your organization class or your employee class, but you are going to implement new operations by implementing new visitor classes. So the UML class diagram, very simple. Okay, the client basically initiates this pattern. In my case, this client is my main program, okay. So element, for each and every element of my object structure or collection, I would say what I do, I will call element dot accept. This is the base interface, basically I element, I would say, which contains only one method which is called accept of I visitor, okay. So the concrete implementation, if you see, it will accept the visitor, okay. And what this visitor do? This visitor will perform visitor dot visit element A, okay, by passing this, okay. Can you see element B and element A are basically concrete classes of your element interface, and they implement the method accept of visitor, okay. It accepts a visitor object, and that visitor object calls visitor dot visit in this UML diagram case, visitor dot visit element A, and it passes this is nothing but passing your element itself to the visitor, and visitor will perform that operation in the visitor class. That's what it is showing, okay. So when this accept method is called, this accept method calls visitor dot visit element A of this, and when this call is dispatched to the visitor, the appropriate method of visit or the algorithm will be performed on that element E, okay. So again, visitor is the base interface, and you can see the concrete implementation of the various visitors. Okay, just a high level explanation. I will explain this with the demo soon. So let's start with the demo. So let me open the studio. So as you can see, I have implemented the various classes classes and interfaces required to demo this visitor pattern. So what I am going to do is, let's go to the first I element, okay. So this is my interface I element, okay, which contains only one method which is called void accept, and it accepts a visitor. And can you see the reference variable type I visitor, okay. So my element or my employee, suppose if my object structure is a organization IT company, then the element of that organization is basically employees, right guys? So this I element is nothing but an employee, you would say, okay. So except I visitor, you will pass the visitor object. So this is the base interface or the contract for the element. Then I will go to the concrete implementation of the I element as per the UML diagram. So this I explained now. I will go to this concrete implementation. So let's quickly go through that. Concrete implementation, employee. Yeah, so public class employee implements I element interface. Okay, the employee has a name. You are setting the name, and then you are implementing the virtual method, or you would say the interface method accept, public void accept. You are accepting the visitor, and on that visitor you are visitor dot visit and passing the element itself to that visitor so that he can perform that operation on the visitor. Same will go for the salesman also, okay. Sorry, one more is, yeah, employee, sorry, yeah. So element is employee. Now I will go to the visitor interface, which I have already shown, it seems. Yeah, no. So this is the I visitor interface now. Okay. uh, this part. Okay. So the I visitor contains only one method, that is visit, and it accepts the element. Okay. So what it does is basically this visitor will basically perform that specific algorithm which you want to perform on each and every element of your aggregate structure or object structure by using this method. So you basically make use of that element and you perform all those operations on that element. So this is just a interface. Let's go to the concrete implementation. Let's go to the trainer first. So I have one visitor called cloud trainer, which I already explained with the example. So cloud trainer implements I visitor. I will set the name in constructor, and then when I perform the visit operation, okay, I will be receiving the employee over here. So what I will do, var emp equal to, I will cast them to the employee, okay, element, and then I will perform the training operation. So trainer name, trained employee emp dot name coming over here, okay, on AZ900 Azure fundamentals. So this visitor, the cloud trainer visitor, performed the training. Okay, he gave a training to the employees on AZ900 certification. Same example, one more visitor, salesman. So what he is doing, same, implementing iVisitor interface and the visit method. It receives the element which is nothing but the employee, and then it performs the salesman with this name, gave laptop accessories and back to the employee. Whatever employee we received over here, that is the element with the employee name. Very trivial example. Okay. Then I will explain the main program. Okay. So when you implement visitor design pattern, so this is the configuration process. First, create the object structure or the collection. In my case, it's organization. Okay, I forgot to show you the organization class. So this is my object structure, guys. Okay, so there is no hard and fast rule that this particular organization should always contain I element. Okay, so basically it can contain any kind of elements. Okay, this is just for the demonstration purpose I'm showing. So as I have a contract of I element, I have defined a interface of I element, and most of the elements which are belonging to my object structure, which is organization, they will inherit from I element. So yes, that's why I have created a collection of I elements. Okay, so this is my organization, and what I'm doing, I'm creating various employees. So these are my employees basically. Okay, and this particular organization or object structure contains a method called perform operation. Okay, so to this perform operation, what you are doing, you are basically passing the visitor. Okay, so this perform operation basically done by passing the visitor, and what we are doing basically. Okay, so this is employee here, say employee. Yeah, that's great. Okay, so for each employee in elements, okay, that is my organization over here. Okay, for each employee in elements, employee dot accept. So each employee will accept the visitor, and as you have already seen, this accept method basically calls the visitor dot visit on that employee itself. Okay, so this way, basically each and every employee whoever visits our organization, they will provide their services. Okay, so let me run the program. So as you would see the program output, so let me go to the program.cs now. Okay, so see guys, there are three steps. First of all, you create your object structure. Okay, so in the visitor pattern, first of all, you should have that collection or the object structure. So I initialized my object structure, which is called organization. Second step, we need to create a visitor. So in first case, it's a cloud trainer. So he is a training visitor. Okay. So I created a visitor, and then on this created object structure or the organization, what I did, I performed the perform operation as I previously explained what this organization class is, our object structure. So on that object structure or organization, I perform the operation by passing this training visitor. Okay, and if you go to this implementation, you can very clearly see what is happening there. Okay, the perform operation basically iterates over each and every employee in your organization and accepts the past visitor. Okay, and the accept method in turn calls the visitor's visit method by passing the this reference or this employee object itself in order to perform that operation. So when I ran this program, you would see trainer Nikhil trained employee Manoj on AZ900, okay, certification or Azure Fundamentals. So if you see, it has gone through each and every employee. That's Manoj, Geeta, Rita, and they basically this particular trainer Nikhil provided training on AZ900 fundamentals. Okay, so if I go to my program, I would see over here. So when I created a cloud trainer, he was a Nikhil. So Nikhil did the training for all the employees. Okay, same way, my next visitor is a salesman. He's basically a salesman. His name is Vishnu. And when I perform organization.perform operation, what he did, okay, salesman Vishnu gave laptop accessories and back to the employees for each and every employees. Okay, so that's all about visitor pattern. So this is very cleanly decoupled. You can see that my object structure doesn't contain any code, okay, related to this various visiting or specific algorithms. Okay, so in my case, it was a cloud training and some sales operation, sales service you would see. Can you see my object structure being coupled with that code? Is there any method which is going to access this elements collection and performing that operation? No. Okay, the organization or the object structure over here is completely decoupled from the visitors, which basically perform specific functionalities or algorithms. Okay, so the salesman and the trainer, these are the two visitor objects basically. Okay, so this is where tomorrow if one more visitor comes, for example, see, today you did salesman, today one salesman came and provided services. Okay, a trainer came and provided all training services. If tomorrow a doctor comes and he wants to give some okay, medication to all the employees, or he want to perform some checkup on all the employees, some basic checkup, then you can very easily go ahead, okay, and create one more visitor called doctor, and you implement the iVisitor interface, and you provide in the visit method, you provide the implementation on what the what all services the doctor is going to provide for the employees. Okay, so you will end up with various visitor classes which are specifically meant for providing some services and which are not tightly coupled with your object structure. Okay, so this is the advantage of using the visitor design pattern. Now it is very easy to maintain and manage this code base because your algorithms are in separate classes and your object structure is not prone to any changes whenever a new algorithm needs to be implemented. Okay, it simply performs a perform operation on your visitor. That's it. Very simple. So, well, that said, let's move on to what are the things we need to consider when we implement this pattern. Okay, first of all, implementing visitor pattern is beneficial when many unrelated operations on an object structure are required. Okay, so for example, in my case, on organization, providing training, okay, providing sales services, providing some health checkups, these are all completely unrelated operations, guys. Okay, so when you want to provide this kind of operations on object structure without modifying it, I think this is the best case to use visitor design pattern. Okay, the class that make up the object structure are known and not expected to change. Okay, so if you are sure that your company will be having a n number of employees, okay, I think this is the fact which is not going to change for any organization. Okay, your organization will always contain employees only. So the classes that make up the object structure are known and not expected to change. Yes, they won't change. Okay, a IT company will never contain a employee, a government employee, or this kind of unrelated stuffs. Okay, they are not going to change. It's expected that the company will contain n number of employees. New operations need to be added frequently. Okay, I think this is a really real world scenario. So frequently you will identify people from the outside world. They will come and they want to provide some services. Okay, it may be a training service, it may be sales, it may be health checkups, okay, it may be insurance. So when you know that new operations need to be added frequently, whenever a new service comes, you have to provide those services to your employees of your organization, then I think this is the best pattern to implement. Okay, an algorithm involves several classes of the object structure, but it is designed to manage it in one single location. Okay, see, when an algorithm involves several classes of the object structure, okay, but it is designed to manage it in one single location. Okay, so keeping your object structure as one single location, and your algorithms and your n number of algorithms will be available to provide services to that object structure. An algorithm needs to work across several independent class hierarchies. Okay, when an algorithm needs to be applied on several independent class hierarchies. Okay, so it is not that there are some possibilities basically. So an organization contains many types of employees like IT department, tax department, accounting department, software development department. So when an algorithm needs to be provided, or when some functionality needs to be provided to independent group of people, that's what this particular point says. An algorithm needs to work across several independent class hierarchies. Okay, so in such situations also you can make use of this visitor pattern. Okay, so one such example is providing health checkup for your employees. Yes, health checkup can be provided to all the employees of your organization. Okay, whereas providing AZ900 cloud certification training only makes sense to your software development teams, basically, or IT teams. So that's what this particular point deals with. I hope you people understood the crux of this particular design pattern. I hope you people use this in your day by day design. Thank you for listening, guys, and have a nice day.